So I'm Dave Lawie, I'm Imdex's Chief Geoscientist.
And I'm John Jackson, I'm Systems Integration Manager for Imdex Mining Solutions.
Imdex is a mining technology company. I sometimes call it the largest global mining technology company that no one's ever heard of. But we are a global company. Headquarters is in Perth, but we supply a lot of technology around anything to do with drilling, really, right through from greenfields exploration through to production drilling, both surface mining and underground. So it's important. We don't drill the holes, we don't own the drill rigs, but we supply a lot of technology around that process and a lot of sensing technology to gather data in the course of the drilling process. Our technology is spread around the world, and in greenfields and brownfields drilling type activities, our technology would be used on 80 or 90% of the world's drill rigs. So that's why we are a global company, because we need to be able to support those activities wherever the drilling is happening.
One of our colleagues was at a unearthed hackathon, the Komatsu hackathon, and Jeff and Lawie got talking and saw an opportunity. So we then followed up with Jeff and started talking and around the CRA conference, where we first saw the avocado picker and the moving of the hay bale, picking up and moving the hay bale remotely, and the philosophy that UFR has of using equipment that's free, easily available, robust, and then automating that platform. Yes, so we're looking at an application of putting sensors in drill holes, and the initial conversation was putting it in up drill holes in an underground environment, and that's still one of our objectives. Another project, which is a Mets Ignited project with Orica, Tech and Anglo American, is around sensing blast holes, and we realised fairly early on we needed a better way from a health and safety and efficiency perspective of logging these holes than is traditionally done on the operations. So we came to have a long, serious talk to UFR, and we're developing the 1AS as we speak, almost finished.
With all of our other drilling technologies, we make use of the drill rig while it's still on site to deploy the technology into the hole. The big difference in the mining production side is that the rig has gone, or we can't, not yet anyway, we can't make use of the actual drill rig to put the sensors into the hole. So we need another system to be able to deploy the sensors down the holes. And so the timing of the meetings with UFR and Jeff was fantastic. And in fact, you can almost say it's got us out of a bit of a bind in trying to get this job done very efficiently. And like John said, a really important aspect of this is working in mine sites. The sorts of equipment you can take onto benches and just drive around is limited. There's lots of health and safety issues to take into account as well. So building or working towards an autonomous way, a robotic autonomous way of being able to deploy the logging tools into the holes and then have it advance along and systematically log at every hole is absolutely key to the success of what we're doing.
And besides the efficiency and productivity aspect, there was enormous gains in health and safety around manual handling, exposing people to vehicle interactions, drill hole interactions, and that's been a real bonus and boon for how this can operate.
It's an important philosophy of the work we're doing in production. We from the design stage onwards, we want people out of harm's way, and so the automation and robotics is absolutely key to that.
So the key aspect from my perspective was they're using easily available equipment, which they're then modifying and automating, which means in remote sites, just about every mine site has people who can keep the equipment, Caterpillar or Komatsu or Voodoo, wherever it is, maintained and up and running, as they do that anyway. So it means that the overheads for operating robotic equipment on site are lowered significantly. And also, because they are mass produced, the capital cost is also lowered.
Yeah.
So it's a really good business model.
And UFR have been extremely agile around our requirements as well.
Right.
Let's not forget that.
No, we've been on a very fast timeline,
This
very
has been
compressed
an
timeline.
extremely fast-tracked project with very high visibility in the industry as well. So you might say that failure is not an option. So we're on a journey together, but it's been
right.
terrific.
Fantastic.
And in a few weeks we'll see the fruits of that journey, and it'll be deployed into its first real-life field trial on site in Queensland, in a Queensland operation.
And what would you say conception to that point in time? How many months? Serious conception. 4 months.
Wow.
It's awesome.
4 months. I think we seriously talked in February where we said, can we actually do this, and can we do it by June?
Yeah.
Fantastic.
Which has actually accelerated that part of the project by about 12 months. We're 12 months ahead of where we thought we were going.